For the correlation coefficient, which we show it by R. In some books, you can see that they show it by rho as well. So here, some books show it by rho. Both of them are acceptable. So with the correlation coefficient, we have this equation for it, like the same equations that we have for these ones, so we can find out the equation for the correlation coefficient as well. But let's see what's the concept of it. Correlation coefficient can be between -1 and 1. So when the correlation coefficient of something is 1, in fact, it means that the two variables that we have, like x and y, they're highly correlated. So when they are highly correlated, it means that we can have a line to connect them together, like to predict the value of that. So, for example, look at here. If I have something like this, like these are my data points. If my data points, they were like this, right? And then I would have a line, let's say the prediction line like this. So with this one, probably the R, or the correlation coefficient, is close to 1. So they are hardly correlated. For example, you can say that for the correlation coefficient, if let's say the oil price and the airplane tickets, right? Let's say if the oil price goes up, the airplane ticket is going to go up as well. So they are correlated in both of them in the positive way. So R is close to 1. In some cases, they are highly correlated, but if one of them goes up, the other one goes down. For example, in industrial application, we always say that, okay, so if we have if the consumption of fossil fuel goes up, right, and the consumption of the fossil fuel goes up, this is another example of the positive one, the greenhouse gases is going to go up as well. Another thing that we can say, like the one it goes up and the other one goes down, most of the time the things that they have trade-off together, so we would with each other, so we would say that they are correlated, highly correlated, but in a negative way. So for example, if the temperature outside goes down, like the outside the house, let's say in winter. So when the temperature goes down, the consumption of the gas inside our homes, it goes up. So we are going to use more gas, or we are going to use more electricity for heating purposes. So we need to generate more heat when the temperature goes down. So in that case, the way that we would show it is like that. They are correlated, look at here, right? But it's like they're correlated like this. So with this one, we would say R is close to -1. Okay? And sometimes they're not correlated. It's like, for example, look at here. If I have something like this, and my line be something like this, we would say that the correlation factor is 0. So it means that they are not correlated. So now let's go back to our question. It says that find out the correlation factor for this one. So what are we going to do? We are going to put all of these numbers, like n14, sigma xi by I minus sigma xi times x sigma y. And then on the bottom, I have the square root of the n times sigma xi power 2 minus sigma xi. So we're going to replace all of the numbers here. And when we did that, the final value is going to be minus 0.9237. So it's like negative 92%. So it's like close to 1, but it's negative. So it means that our variables, these two, they are correlated, they are highly correlated, but in a negative way. So if one of them goes up, the other one goes down. Even when you look at the equation here, you can see the slope is negative. So the line that I'm going to have for this one is going to be similar to this line.